So given that cosine theta is 3 square roots of 13 over 13, then theta is in quadrant 4. So actually this is enough information to know where to build our reference triangle and our reference angle. Theta's in quadrant 4. So we know our angle terminates somewhere over here. So let's make a right angle with the x-axis. And now let's evaluate, let's see, we need to figure out what sine of theta is. So cosine is the adjacent, and so this is our angle theta, so this would be the adjacent divided by the hypotenuse. So I hope that's okay with why I wrote those there, right? Because opposite of theta is over here. And then this has to be the hypotenuse because it's opposite of the right angle. So this has to be the adjacent. So this is the 3 square roots of 13, and then the hypotenuse is 13. Now we just have to find that missing side over here. Okay, so we can do that by doing 3 square roots of 13 squared plus b squared. That equals 13 squared. So if we do that, 3 squared makes 9. The square root of 13 is just 13 now. B squared equals 169. So 9 times 13, that makes 117. Trying to get b squared by itself, so let's subtract 117 from both sides. So we have 169 subtracted by 117, that makes 52. Now we need to take a square root of both sides. The square root of 52 is that opposite side. And I think, yeah, we could reduce the square root of 52. I've just been seeing Newton is okay with this answer though, so let's leave that for a second. Sine of theta, oh, actually one last thing. Sorry. Put a negative in front of this because you went down on the y-axis, right? So we're going to say that's negative square root of 52. Because now sine of theta is the opposite divided by the hypotenuse. And so that's it. That's our ratio. So negative square root of 52 over 13. Let me see if get that question right here. Negative square root of 52 over, what did we say? 13. Sorry, just looked at the title. It says use the Pythagorean identity. The Pythagorean identity of sine and cosine says that sine squared plus cosine squared equals 1. And that comes up a lot in calculus. We use that a lot to help us evaluate some integrals and some other weird stuff. So, and if this is the first time seeing that squared on top of the trig function, that might look weird. And it did to me when I first started studying trig. So, just so you know, this is the same thing. Okay, so the other way of doing this problem, other than what I just did, what I did works, but if you're trying to get sine squared theta, you could plug in 3 square roots of 13 over 13 in for cosine, square it, and then solve that equation algebraically. Just remember, when you take a square root, you get 2 answers. You get a positive and a negative answer. So to decide on which one is the right answer, you got to use this fact that it's in quadrant 4. Sine is negative. These are the only places where sine is positive. Right? Sine is negative in the 3rd and 4th quadrant. So that's another way of doing the problem. I didn't do it exactly the way this title says, but definitely works.